there is 4 user needs that we have listed. The first one is complete insect elimination. The second one is lower labor dependency, which is we don't focus on the labor all in. And the third one is cost-effective chemical use, and the last one is durable and low maintenance system. Next. Alright, so this is our solution introduction and our value proposition. So how it works? Automated smart pesticide dispenser for durian orchards. Our solution is an AI-powered automated pesticide spraying system that eliminates insect pests with precision while reducing labor and chemical waste. Alright, so our value proposition is we listed at least 3. The first one is 97% insect elimination. The second one is 50% lower labor cost, and the third one is 30% less pesticide use based on our benchmark, which is the hanging and also the manual spraying. Alright, so our system adheres to the first one is FAO and WHO pesticide guidelines, which is safe nitrogen concentration less than 1%. The second one is MPB, Malaysian Pesticide Board regulation. The third one is occupational safety NIOSH standard, and the last one is export market requirements that been listed by EU and China. Alright, next. Alright, so this is our benchmarking table. We have used the spraying method and also the hanging method as our benchmarking to compare it with our product, which is the smart dispenser. Alright, so the criteria is, the first one is effectiveness in pest control, the second one is impact on durian quality, and the last one is cost efficiency. Alright, next.
Next, we move on to design specification level. Okay, first off, users need to use a less pesticide usage and easy maintenance at a low cost. So it's pretty straightforward. Okay, and the next one, the design keywords is you need to have an efficiency, easy application, and lower operational cost. So in case if you want to make it on target, we have our clear goal, which is we need to reduce our pesticide by 30% and have our maintenance by roughly once a month, and a lower labor cost, which is under 50% of what we have now. And we also have which is safety and digital setup. And we also have an even future idea, like we make it more automated. Okay. Based on what we talk about, so we come up with our design analysis. So this is the parameter that we need to calculate. The first one is area and value. We need to determine our concentration and volume of the pesticide, the pump power, so that we can make it through the top, the power supply that we can use, the type of nozzle and the angle of spray, flow rate, pressure, and time density. Next. Okay, this is the overview for our smart pesticide sensor. So basically, you can see that there is a pesticide container that connected to the water pump. The water pump will push the solution through the pipe to the nozzle at the top, and the nozzle will spray the solution to the surrounding. And we have also the SP32, which will make the automation spraying system. Next. Okay, we can say that this is our result of our calculation. We calculate that we need to have an area of 64 meters square and a volume of 640 meter cube to specify the area. Next. Okay, this is our calculation for the nozzle. Next, this is our flow rate. Based on our flow rate, so that we can determine the concentration of our malation, so that we can calculate for each cycle how much we need to use. And this is our calculation for volume per cycle, which is one nozzle we will use 1 liter of water and 10 milliliter of malation. So this is the type of pressure nozzle. We have
achieving that engineering target. But the way I can see on your design analysis, can I see your design analysis? Okay, stop there. So this is what you are looking for on your design analysis, right? Area, volume, in which I don't see that in your engineering target. So I can see that you make calculation to get your focus on area and volume, and you make calculation for nozzle design and pump power, right?
Yes.
Like, how does I don't see the relationship between your design analysis with your engineering target. Okay.
So basically, I can go to the next slide. The volume, calculation for volume. Okay, for example, for this is volume per cycle for each nozzle, which is one nozzle. We have 1 liter of water and 10 milliliter of molecule. In current situation,
From where you get to?
we calculate from the concentration that we needed. So we
Again, the concentration. How did you need that concentration?
pardon?
How? Where did you need? Who said you need that concentration?
So basically, our concept is we use the concept of smell, where the smell can impact the bulk. So we calculate, we find the minimum concentration that needed, so that the smell is there. So when the last hour we calculate, we try and error, we find that at 12 hours this concentration is okay.
Good. Still, where did you get this? Based on what? You get that number or that smell or that amount or whatever.
So basically, we find the study online. So yeah.
Okay, and how is that related to the user need? How is that related to the customer?
Yeah, based on that, we calculate the minimum value that we require, so that we can get this the good situation.
Okay. You went for, I don't know what is in your head to get the solution. My point is, if I go to your first slide, go to your first slide, the problem. Okay, no, yeah, this one. Okay, so here the problem is the pest or whatever, right? You have durian, eliminate insect pests. Basically, that's it, right? That's the problem. So how did you get that? What type of pest is this one? How do you know that amount or whatever you said of repeller or something will affect this pest? That's my point. Where did you get this info? If you get that one, that should be your design target. Because you use that one to do all your things. So your design target is not 30% of I don't know what, which has nothing to do with your calculation, the 30%. You understand? No. Okay. My point is, this calculation, you start, okay, I need this much, 1 liter, and 10%. Why you have that liter and 10%, for example? Why that liter and 10%? Is that the amount that it will kill this insect?
Yes, sir. So based on the study, it says that if you want to follow, can you go? Okay, this one. Alright, so based on our study, it says that it is enough for only less than 1% of the methadone to kill the insects. So if you want to if you want to follow this the regulation, which is the less than 1%, we need to we have combined it with the water also, which is 1 liter and 10.
All right, and this 1% is specific to the insect of the durian?
Yes.
Okay. So this one, if this 1%, so where is that 1% is involved in your calculation?
Can you go to the
In the design analysis? Is this one the volume?
So for volume, yeah. So we want to use 1 liter, so 1% from 1 liter is 10 milliliter.
Good. So now you go back to your engineering target. Okay. No, engineering target. The other table. Okay. So this one, the efficiency, right? It not be the target. Your first thing should be 1%, or my solution have 1%, or at least 1% need to know blah blah blah, whatever it is, right? Because that one will kill the insect. And that's that 1% you started with it. You did the calculation, you found the volume, and then you found something else. So that 1% should be here. That's actually your one of the engineering targets.
I think we have miscommunication about this because this is based on the benchmarking actually.
No, but what's the benchmarking? This actually, it has to be the one that will enable you to characterize each component of your system. Now, you give me some numbers here, and you want somewhere else, and you start doing calculation, nothing used from the engineer target. So who said that solution is for this? Is not. That's my point. Even though maybe it is because you write it wrongly or whatever it is. But as external account, I look, this is the target, I found your solution, I said, this problem, this solution, they don't fit. You're designing something for something else. Okay? So my second one, like this one, let's just say the reduction 30%. When did you use that 30% in your calculation? In the design analysis where that's involved, the 30%? I think all of you are, making things as kind of robotic, We told you to fill a table, you fill a table. Do this, do that. But you don't even understand or you don't think what is the thing. Like we said here, this engineering target, the number you put here, that's the start of your design analysis. So you're going to start from that and see that one is related to which component from your solution. And then you see, you link it from your previous knowledge, from the literature, from whatever, then that reduction somehow is linked to the pump. Somehow, I'm not sure, right? And then you see from there until you find what is the pump power or something, but you started from that to achieve that 30%, which pump I will need. So that's the point of this design analysis. So here I want to see each one you put here, that frequency 1 month, 50% cost, 90% whatever, how is that related to each of the components of your system? That's it. Yeah, go ahead. You understand?
Yeah.
Can you explain your design analysis, or they are not linked to this?
Basically, the design analysis for 30%, there are some relation from our calculation, but we don't include in the slide. Because in calculation, we get that for one system, 4 nozzle, right? So we can cover about 10 trees. So you can see over here, one system, this is one system, we have 4 nozzle. So we can cover for 1, 2, 3, 4, 5, 6, 7, 8, 9 trees. So we use 4 liters, almost 4 liters water and pesticide. But in normal situation, they use 4 liters for about 3 to 4 trees. So there are some relation over here, but we don't include in our slide.
Okay, still not good enough. What you did design analysis. You said, okay, this I need 9, and then they do 3. So since I use this, I calculate the difference 30%. Still, you didn't use the 30% in your design. I don't know what kind of assumption, but let's say here for the regular one, which one the regular? Is the 5 trees or 3 trees or whatever?
The regular, the current situation we don't include in this slide.
No, but you want to, that one it consume whatever, some amount, right? You want to use 70%, and you're going to reduce 30%, right? So you can cover the same area with 70% of the pesticide, is it? Yeah. So where is that calculated? How you came to this, like you can cover 9 trees?
So I think we need to improve in that.
That's why you have your thing as an idea, and then you make sure that your calculation fits what it is in your head, which is not the design we want. The design we want is you put some target, now you start from those targets, and you design your nozzle, your pump, your battery, your thing. And then to verify if it is working or not, you don't do it now. When you do your prototype, that's what we want to see, your validation, to see that if your design analysis is correct or not. But now what you're doing, you do some calculation, you say, oh, so then I use it 10 liters. It's all calculation, not based on your engineering target. Just I have this nozzle, I spray this much, I put this liter, and then, okay, I save 30%, I get 3 trees, okay, so now I get 9, he gets 3, so yeah, I get 30%. That's not the way we want it. Okay? I want you to start from how to achieve that 30%, then go back and find the component that will allow you to get that 30%. That's the IDP philosophy. And not only you, I think most of the groups, if not all, I think they didn't get the idea of the design. They do the design like in the course. They do the calculation and then they verify after. Oh, mine, it gives me 100, so it is better than the other one, it gives 50. So it's 50%. No, that's not the way. Okay? If I go to your target user, how can you achieve all these target users? You have 4 target users. How they are linked in this one? I thought your target user is only the first one. Why orchard owner and manager? Why they need your solution? Because those they might have some other target. They want to increase the production by this much. They want to make it smooth. Well, it's completely different thing. Probably it's not the same. No need actually. You think like to make your things more, but actually it's not. It's making it even more. Or like maintain export quality fruit. How's that? Your solution is for that specific guy. Is for him? Is this just a pesticide problem for the quality? There's other things probably for the real quality. So his engineering target or his requirement will be different from the first one. Yeah.
So why we list at least 4 of the user is that the first one is legit, which is the medium to large scale performance. Alright, so for the second one, orchard owners and managers, they of course for the managers and owners, in our engineering spec also, we focus not only to kill the pest, but also we want to reduce the cost. We want to maintain the healthy of the tree itself. So that's why I think the owners and the managers also.
How you helping in the health and the stuff of the tree?
Because based on the traditional spraying like this one, it causes the tree to be unhealthy because it is overspraying. But and this one, it is not effective because the coverage of the pesticide itself is not
Still, this is, like you said, this is what you say that one. It's like that one, leading to. So this is not the problem. This is, if I don't spray properly, I might lead to this.
Yes.
But that's not the original problem. If I do good spraying, I don't have those issues. They won't happen. So I don't have to solve it. So just solve the spraying problem. Your issue is the spraying problem. You understand? The other, because their spray is wrong, so it caused the tree to be this.
But however, in the proposal presentation, we have included the case study shows that when we don't spray properly, there are some reduction in the value.
Good. So again, what is the root? What is the problem? The root cause. What is it?
This pest and
No. From this case, what is the root cause? It's the spraying. The spraying process is the problem. So if I fix that, then all the other are symptoms. You understand? So if the spray is not there, then the tree won't have any health problem or any other things, in a sense. Okay, it has from the past, but different story. My point is here, you try to focus on the spray. So when you see the spray, then eventually, that's why, like I said, it's a symptom. If I don't do good spraying, then the tree maybe will get sick, the fruit maybe no. But let's say now I design a good spraying system. So the right amount, then I spray only the area I need to spray, and this, then I don't have any other symptom, they're gone.
Okay,
I don't have
so
to design anything for them.
what you mean is we need to stick with one root cause only.
Because that is actually your root cause only.
Okay, alright, we understand.
The tree doesn't get sick if you don't overspray it. The fruit doesn't get spoiled if you don't overspray it. So it's all from the overspray. The fruit getting spoiled is not a problem. It's a symptom. Yeah, you understand? That's why we said at the beginning you have to differentiate what is the root cause and what are the symptoms. You know, this one is like you get sick if you don't get healthy, then you get even sicker. And so I'm going to solve the sicker thing. No, let's solve the first one, so then you don't get to the second stage, right? So here it's the same. For me, it's only the first one, the orchard, the durian farmers, and then the spray. And then for the spray, I have this one. It's like they don't kill all the pests, they overspray, they blah blah blah, whatever. The problem with the spray. I think this is what I mentioned also in the proposal. And you focus on that, and then you get the percentage. So why they don't get all the insects? Because maybe it's diluted, doesn't have the right content. So now the solution has to have this much of nitinol, so then it will kill the pest. Then the spray, because now they use whatever, I'm going to make a nozzle, and I design my nozzle, then it will cover, let's say in my durian, the area to be covered 1 meter by 1 meter, then it should cover only 1 meter by 1 meter, for example. So now my design it is area to be sprayed 1 square meter. That will be my engineering target. And the other one, I don't know what is the other one, it's the same. So it has to be from this, like, and then coming from that, then now you design what is the pump you need, what is the nozzle you need, diameter, blah, 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 etc. Okay? Then it will be more focused, and it will be actually, like I said, your solution will be fitting to the problem. Okay? And make sure your user needs also, like you mentioned before, consistent. You don't have here one user need, and then later, if you go to your other slide, can you go to the next slide? For user needs. So you have this complete insect elimination, lower labor dependency. I don't know why that one. So how that's lower need to have less labor?
Yes, sir.
So
Because as stated in our tech user, there is also the managers. So the managers, of course, want to maximum the profit. So one of the way is lower labor dependency, which is we cut the 50% of cost for the labor by manual spraying.
So from this one, how do I get that? See, from here I have only the insect. Can you go now to your engineering target table? So here what you have, reduce pesticide usage. I don't know, that's nothing for the elimination of the insect. What is the elimination of the insect here?
They reduce the stage.
No,
It's the first one.
no. That's not to eliminate, that's go back. Reduce is like this one, no, go cost-effective chemical use. I will lead to that one. Because you want to use less pesticide or optimal pesticide. So that's kind of the one. But how that complete insect elimination? That means I want to eliminate, like whatever insect, when I spray it, it will die. That's what it means. I mean, it doesn't mean by the percentage of 30% of what is that? No, this infestation, right? That's the thing. So that's okay here. complete, and then you want, because now looks like with their spraying, still 50% of the things they still survive or something, right? You want to eliminate 100%. But in your engineering target, they don't see that. In your table, there's no saying that your thing is 100% effective. It's killing all the insects. There's nothing there. You talk about reducing the amount, increasing the amount, which is other. So it has to be aligned, you know. So make sure that for that one, whatever you have, maybe 1, 2, 3 target, but that's the main thing. Actually, is number one. The main one is number one, and the second one maybe I don't like cost effective because you're not for the cost here. It's like for the right usage, you know, the right amount, the right area to be covered, etc. So it's kind of the different from cost. It's not the cost here. I don't think the cost is important here. What important is the amount of the pesticide to be used, which obviously it will affect the cost, but that's not the main thing, and the area that we do. So then I just cover what is needed. So then I don't damage the fruit, I don't damage the tree, blah, blah, blah. So that's these two actually major things I see from you. Your things, then this has to be adjusted as well as your engineering target also has to be. And of course your calculation has to be redone. Data from the target. Don't give me calculation for the sake of calculation and then at the time you say, okay, it is worth it. No, that's not my point. Okay? All right.
Can I comment just a little bit on your design analysis? Okay. Regardless whether it's relatable or not, just want to comment something. Next. Okay, this one. At least put some level because it's hard for me to understand what are you trying to do. Like all the crosswise there. Then I know it's 3. Put level 3. And what view is this? Top view.
Like legend, sir.
Sorry?
Like legend. Legends for X is for
I
C.
understand. But instead of just putting like this, put some levels so people can quickly understand what you're trying to convey. Like the volume need to be covered. What is that circle? I know that's 3 lah. Now I know it's 3, but it takes me some time to know that okay, this is actually you're talking about trees. And so just put proper labeling so that people can understand. Not everyone is smart enough to truly understand what you're trying to convey. Okay? I think that's it.
And no copy and paste like this. I've told you many times. I cannot see anything here. I don't know how you can see that one writing over there, for example, the number. Okay? So make sure that, and you don't have to show the whole, like I said, calculation. Just make sure this is the component. The nozzle, I want to find the diameter of the nozzle. That's my unknown. The H is fixed because of blah, 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 for example. Right? Then using, I don't know what, Bernoulli, whatever this, whatever equation, okay? Then I find that the diameter is this. That's it. That's what you need to, for each component. But starting from, what is the engineering target involved with that? Is it the 30% reduction? Is it this, and then where it is involved in the calculation? That's all. For each component, it goes like that, and maybe one component that. Because like here, like also you put 4 types and things, it's too much, and then again, you cannot see the number and stuff, so it doesn't have actually give you some negative remarks. All right?
Okay.
Thank you so much.
So this is group 4, huh?
Okay, shall we have next group to present? Volunteer? I guess it's prepared.
Can you set?
Which group? 10?
Group 10.
Yes, we have from group 10.
There are only 3?
Actually, we are 4 members, but one of our members can
Make passport.
Oh, passport.
Okay.
This is a Taiwan group.
Oh, he wants to purchase a new passport today. Yeah? Today, 11:30 to 1 o'clock. Is it by appointment or what?
Later, I will ask him.
It's okay, it's not you to justify it. It's his problem. It's his problem. He will be absent anyway. Go ahead.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So we are from group 10. Before I start, I will introduce what our project. Our project is about smart transfer patient. Next slide. Next slide is our name. Our solution name. Okay. So, as we know, emergency department is the heart of each hospital, very close with fast-paced, high critically dependent on teamwork, right? So, but behind the scenes, there's a silent struggle affecting our most valuable asset, which is our medical staff. Our medical staff, which is nurses, MO, porters. Unfortunately, we always see the safety of the patient, but we always neglect the safety of our staff, which is the porters, MO, and nurses. So, our problem identification: porters in emergency departments are highly prone to musculoskeletal disorders, mainly lower back pain, LVD. So, which is here the data we get since 2000, data from 2019. Sorry.
I don't know.
Can you see? Here stated, which is mobility patient. The fact the porters that leave patient back to back was 85%. So there's a problem that we neglect. Okay, so the root cause, the first one, frequently lifting patient from back to back, based on the data, and then high patient volume in emergency department. If in the emergency department there's light patient, so it maybe can give some burden to them, but nowadays a lot of patients are obese, more than 100 kg. So the impact, high rates of lower back pain among medical staff, leading to chronic injuries, reduced workforce efficiency, and increased medical leave. So here we provide a picture on how they transfer the patient nowadays with the spinal cord. Alright, next. So jobs to be done. Our main task, which is to ensure another safe, efficient, and strain-free patient transfer from back to back without relying on power system. No motor, without relying on power system. Okay, so our target users is porters, medical assistant, and caregivers, and the user needs reduce lower back strain, improve workflow efficiency in emergency department, and safe patient transfer. This justification we got from our primary research, which is we have an interview with our one of medical doctors. So studies show lower back strain are common among healthcare workers due to manual handling, because he said that his member as a porters always tell their pain. Okay, porters often work long shift and handle repetitive lifting, leading to injury risk. Manual tools with ergonomic design offer low cost really needed in hospital setting. Next. Alright, so auto decomposition, which is we can reducing mass skeletal strain of the waters, and we can enhancing patient safety and comfort, and also the scalability and adaptability. Okay, compliance standard. We follow the compliance the standard of OSHA, Occupational Safety and Health Administration. And then also ISO 13485 and FDA +1. Alright, next. Right, so benchmarking table. We have several features. So we have five features here, and the first one is power required, and second one transfer time, third one training required, and fourth maintaining needs cost. So as you guys can see at the slide, the other product like power required manual device, for example, power required, non-power required, transfer time moderate, training required moderate, maintenance need very low, and cost low. But they give some back pain to the porters. And for our product, also power required, we have no power required, just a little bit. Transfer time very fast, training required minimal, maintenance need medium, because we have also the maintenance, and cost mid-range around 2000. Design specification table. Alright, so for the user need, we must have the first function will reduce physical strain. About the design trigger, it incorporates a built-in sliding platform using low friction rollers to minimize effect during horizontal patient transfer. And the design characteristic system utilizes a linear bearing or roller track, allowing the mattress to glide smoothly between beds. Engineering target, estimate force to initiate transfer around 30 Newton only. And the coefficient of friction on the roller is 0.03. Less than 0.03.
So, did you, first of all, did you practice? You know, you see, like, this presentation is for 10 points. The problem identification and benchmarking for 2.5%. You spend 5 minutes or more on the 2.5%, and you miss the 7.5%, which is the design analysis, the target, the design spec, etc., which is the main thing. You talk too much on the problem and going over and over and over, you know, and benchmarking anyway. Hopefully for your final presentation you make sure. If it is 1%, then I will give it 1%, you know, of my time. So I don't give it like 90% of my time. Anyway, that's what presentation was. Alright, I'm not going to talk this time. Every time I take all your time, guys. Yeah.
No, we are okay because you usually cover everything.
And can we just show?
Sure, of course, sure. That's it, but you don't, no more talking now.
Right. So this is how we design.
Yeah.
Is in order.
Next.
This,
No talking, that's fine.
this is like
You have your 7 minutes, you wasted your 7 minutes.
belong to this one.
50 gold transport.
It just costs 180
For what?
one set 25, one set. So
Okay, will you go to the benchmarking table?
material and the bill of processes, guys, all of you, you're confused between them.
Still confusing.
Bill of material, we need to see the spec. I don't see anyone putting the spec, except maybe that
Yeah.
group. Anyway, okay.
Alright, so how did you benchmark this? So the red one is what? Like the good characteristics or how? Or is it like the no part?
The good characteristic. The red one is the good characteristic we want.
Okay, so that's I got quite confused because how are you going to highlight the product with this type of benchmarking? Manual, you compare with manual, air assisted. How are they different?
Actually, before even you go that deep, I want to go from the beginning, fundamental. And how are these features are linked to your user needs? Why they came, from where they came, this feature, I didn't see them why they are important, because I don't see them in your user needs. Your user needs, there is a back reduction, there is I don't know what, there is nothing to say transfer time has to be quick, or the power required has to be good, or training. Can you go to user needs? There. No, there.
Reduce lower back strain.
Reduce lower back strain. I don't know. Is that time related? I don't think so. Safety patient transfer. Time related? I don't think so. Improve workflow efficiency in the emergency department? Maybe. Maybe, but not, it's not 100%, but maybe a little bit there, right? And how's the power is involved here?
Lower back pain. How do you calculate reduce lower back pain? How do you measure that? Yeah, how do you measure it?
How
Measure that the strain is already reduced. Lower back pain. How do you measure that you have reduced lower back pain?
So basically, the procedure of first we currently processing patient is two people is lifting one patient, right? So that causes the lower back pain strain, and then what we do is we
No lifting anymore?
no yes
No lifting, right?
no lifting. We ease the transferring patient by the next slide, which is the patient will get onto the slide, and then the porters will only pull or push the slide on the into the next bed.
How do
So
you calculate lower back pain?
No, they don't.
Yeah, that's fine.
Probably you shouldn't put it as a reduced lower back.
So the need is actually to not to have need to lift the patient itself. That's the user need, right? Not to have use your own
yes.
energy or your strength to lift it.
So now how the transfer will happen now? With your solution? How the transfer of the patient will occur now?
Now, like our solution or right now, the method they already they use. The method they already they use. They will put spinal board in between both backs, and then usually they will have three.
You have a drawing? You have a drawing of your solution or no?
Your solution. Can you show your solution? How are you going to?
That's not still not the solution, but anyway. I want to see it, like you said, the first picture you have that patient laying. So show me now how your things will happen. But anyway, it's okay. So now how it happened?
So we have two beds. And then one of the beds will install this board, this light.
Go back to the picture with the patient. The first slide.
First one.
Yeah, like this one, okay?
Right. So the bed, ED bed.
So now I have this patient. I want to transfer him to another bed. So
Right.
how? Tell me.
So this is emergency department bed that already installed our board.
Okay.
Okay. And then just one porters, they will push.
So you slide.
Yes.
Slide to the next bed.
Yes.
Push the patient or what?
Push the board. Push the board. Push the board.
Okay, so that one, all right. So before what they do, they take the patient, right?
Yes.
They take and put from one place to another.
Yes.
Now push.
Push. Yes.
Okay, so now how do I know that push, it will reduce the pain back?
Because we have rollers that will decrease the.
No, theoretically yes, I know. But for you, because you have to have either an engineering target or you have to make a measurement that now the back is 70%, now with the new one it will be only 30%. For example, I'm not sure. How that one, do you know? Any because they say I use the backward solution now and I will do this one. How do you know now my pain is there or not? I mean, I'm not sure. Or it's reduced at a long term that it solved the issue.
Because usually the current solution need to like the quarters need to bend a bit and then cause a lot of angles between the waist and then the body. And current solution we just like level up it's not level up, but the board is the level is
Okay.
same as the waist.
Okay, so see what I will see for this design. I won't say the lower pain, blah blah blah. That again probably it's a symptom for me or whatever it is, but not for my target. My solution it won't have same as the other guy. My solution it won't have the issue of lower pain anymore. But now my solution maybe it will be more since I'm going to push. So make sure that I will just provide like normal push, like to get pain, for example. You have to look for it. Like if I push like this, I might strain myself. So more than 200 Newton, for example. You know, it will cause that. So I have to provide less than that. 50 Newton only. Quarter of that. Definitely that's the healthiest things I can do. Even now here I can do this one, you know. So make sure that I have that. If with 50 Newton I can push them. Then you design your roller, your blah 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 in order to be able with that 50, that 100 kilonewton person can be actually moved easily. Then I design my component based on that. So then my engineering target is not like the pain, but it will be, for example, the power or whatever the force or whatever that this one has to provide. Normal, they will provide, let's say, when it is too hard or too painful, it's when it goes beyond this level. So I have to go below that level, then I know that it won't have any pain. Then you save yourself. Right? So they tell you how you measure, he said, okay, because the pain, if a human above 200 Newton, they exert something, it will create some strain for them. Right? So if it is less than that, then nothing will happen, for example, or it is safe. So I will go even more. My solution, instead of just below 200, I'm going to ask that my solution only with 50 is a quarter of that, and then it can work. Then you will be on the safe side. Okay? The other user needs. Safe patient transfer. How you ensure that one? What is the engineering target related to that?
Because since they are lifting, so it might cause the patient more pain. So with our solution, we can avoid the problem.
Okay.
So
Again, see, your solution for me, based on your explanation, it does not need any design. You understand? Because all is not related to engineering targets, but it's to the logic. You know, now I lift, now I don't lift anymore, so no pain. Okay, done, I solved that issue. The other one, because we lift, maybe sometimes we drop him or unbalance and then he gets shaken, whatever. Now, since we're not lifted, also it's safe. So I just push his goal. So what do I need to design? Nothing. I just make a roller, make something that just he will move. That's it. What is the design here? See, that's my point here. your things is not related to design things. So, but if you say the pain is caused by 200 Newton, so I designed for 50 Newton. I solved the pain. Now the other, usually what are the problem when they lift? Because when you say it's not safe, what happened to him? He got rolled over. He fell down. They drop him. They, I don't know, twist him, whatever it is. Now my solution will prevent all those. So it will be no twisting, no dropping, no, I don't know what is the things that problem they cause. Then they will be my engineering time. So I have to design my things to prevent that. But now, the way you explain it and you have your solution, because we don't do that, then he won't have. Because we don't do that, my solution, then he doesn't have. But how did you design your solution first place?
If we design our board, that the angle of the board is 0 degree, which is left, and then the height of the board and the bed. So
No, you don't understand my point. See, you're going for the solution now. I want to see what are the issues. Let's say when the patient, can you go back just clearly here? I'm not even going for the calculation because I don't think you are on the right path. Yeah, this, no, go back with the user needs. Like I said, for reduced lower back strain, you have to say what is that. Like I said, if it is the lifting, the thing, whatever, the pushing, the force exerted that causes that, then I have to reduce that. That will be my engineering target. Then I can solve that issue. The other one, safe patient, transfer. What is, let's say, what is not the non-safe? What happens if it is not safe? What are the issues? What are the problems? He will be dropped. Is that the worst case? They will drop him? I'm not sure. It happens that they try to transfer a patient and he got dropped because too heavy for them or something. I'm not sure if it happens or not. Right? Or let's say you and me and you are stronger. So you hold, but me I cannot hold, so he comes on my way. I don't know. So you have to see what are the issues with that safe patient. Then I have to make sure what is that one. So keeping him flat, for example. Keeping him, I don't know what, whatever. Then I make sure that will be my engineering target. So then my solution should be like that, you know, the 0 degree, the blah, 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 whatever. If I design that, so then I will keep him that one, so then he won't fall, he won't flip over, he won't, I don't know what. Same for the one. Improve workflow efficiency. What does that mean? What do you mean by workflow efficiency?
Gradually, the current solution need to use at least 2 bottles to transfer patient, but our solution need to use at least one, only 1 bottle, that's one.
Okay, so how is that improving workflow efficiency?
And
Because workflow, as if like, I'm going from this step to this stage to this stage, that's the workflow.
Because the current solution leads to another problem such as the lower back pain, right? And then let's say another, the next week the bottles get lower back pain, and then she or he might take the lift, so the number of bottles will go decrease. That's why our solution will reduce the lower back.
Then it's not workflow. Workflow, you know, workflow, that means okay, the patient comes, now he registers. Second, he go there, he be tested. After he go there, lay on the bed. After that, transfer him. So how your solution is improving this workflow, I don't see. It's working on the workflow.
Steps. Now, with the solution, you said that it reduces the workflow. After step, it becomes 8 steps.
Exactly. So that's workflow, what it means. But here he said maybe efficiency, I can maybe live with that one, I'm not sure.
So how you improve the workflow?
Yeah, that's why you should remove workflow. There's no workflow here.
I think we use the wrong way.
Yeah. Maybe efficiency, whatever, you know, something like that. Or maybe that reduce time, that you can put time there. Yeah? Make it faster or something like that, right? So then it will be more specific. And then you can relate it directly to one of your engineering targets now. But efficiency also okay, because efficiency can be time, can be this. But when you put workflow, it becomes something else. Okay? So it's like you reduce it, like Amir said, that you remove some of the tasks or you expedite some of the tasks or something like that. Anyway, yeah, I think please make sure in your final presentation you got all this. I hope you, I think Amir will register that well. Maybe you can listen to all this if you missed whatever you didn't register all commands. You can get the recording and then you try to address those in the final one. Making sure it is consistent. Your benchmarking should follow. You don't come with a new feature that is not here, not linked to your user needs. Okay? So all the features you want to compare, they have to be directly related to your 2 or 3 clear also user needs. So when you say safe, I want to know what do you mean by safe? Then in your things you put safe, that means doesn't flip over, doesn't fall down, doesn't I don't know what, keep an horizontal position. I don't know what is safe. So you have to check that what you mean by safe, right? So that's those, I have to make sure those conditions of safety, they are achieved in my design. Okay? Then I design my plate, my angle, my whatever thickness, my things based on that. Okay? All right. So because this one, I think your engineering target. If I go quick to engineering target, but I didn't see them. Also, make sure we mentioned this many times from presentation one to be visible. No point to have like this and then we cannot see it. You cannot read it, right? Like that table that we showed in the first slide. This justification here, I have to do like this to read. Okay.
Your box is big, but your font is small. You're trying to hide something.
Dekat sini pun dekat sini aku kecil pula.
It's really small. You should consider how to project it.
Yeah, but even there is big, here is small, that's it. That's why we said you have to try it. You don't, that's why sometimes actually I understand that. I have different color on my slides. Here they come different colors. So I have to make sure that what I did, and I use with this very advanced projector, that it gives me what I want. You cannot blame it on, because you should have come earlier and checked. Anyway, it happens that one. So, can you engineer target quickly? Any other group? Is other one? That's it.
That's it.
That's it? Oh, then we cut it. So, like this one. All right?
Prof, you have until 1 o'clock. Another 14 minutes.
No, 4 minutes until 12:50, like the right time. So here one, estimate force to initiate transfer 30 newtons. See, where did you get this force from? So 30 newtons, is this the one to push him?
Yeah.
Huh?
We do the calculation.
What calculation?
The analysis. We do what?
How did you get the 30 newtons?
First we calculate the force that we the force or the load on the slide, and then we divide it into the length of the slide. So to get the distributed load, and then from that we can get the bending moment, and for the coefficient of friction just now, it's based on the material that we use on the roller that will slide the back.
You know what? You know what's your engineering target here? It's not the 29 newton actually. Your engineering target here is to be able to transfer a patient that has weight of 150 kilograms. Because that's what all your calculations started from, right? So you start with the patient 150, then what is the 150? What is the 150 involved? What is it? Or is not involved anywhere?
Which one?
The 150 kilograms, the patient weight.
This one? 150
Uh-huh.
multiplied by times.
Okay, so you get the weight. Uh-huh. And where is the weight after that?
1471.
1471.5.
And then you divide it by what is that?
The length of the
Distributed. So you find 700 Newton per meter. And then you have used that one to calculate the moment. Bending. I don't know why you have bending moment here, but okay. So you have your plate and then you have the weight on it. Okay, why is the bending moment is important here? Bending strength. And then to find what? The thickness. No.
no
Area.
to avoid the board from
decide on the thickness or the property of the. This one for what? To calculate what?
To calculate to avoid the board from bend.
Bend.
Yes. From failing.
But you have a bend moment here. So then after that you do what, sigma 250, whatever, I'm not sure that what is that one. And then S here is M over sigma.
So maximum bending moment we use to calculate the bending strength, which is how much the slide can withstand the load. So we calculate the bending strength, and then we got 3090.1 mm cube.
I don't understand here. All this calculation is for what, really? Are you designing the roller, or you designing the what do you call that? Not the plate, the board. Is that what you're designing here? Is it for the board, this one, or for the roller? Both. So for the board, how did you decide? See, first thing actually from this, like I told you, your engineering target is 150 kilogram. So your engineering target, if you go back and then come back to this slide. Yeah, this one, no, go back. See, this one, reduce physical strain, I don't know what is that, and blah, blah, blah. But actually here is to, engineering target is like, maybe not reduce physical strain, but whatever, transferring, reducing physical strain when transferring patients. And then on the patient it will be the weight of the patient there, or the mass, and the engineering target will be 150 kilogram. That's the biggest kind of whatever patient you can transfer, right? Then, now go back to your other slide. Now your design analysis becomes correct. What are you doing, right? Yeah, next. The calculation. So this, see, you start with your engineering target, maximum patient weight 150 kilogram. If you go to that one, the weight 147. Then, see, you use that 147 over 125 there to find the force of the roller, for example. Okay? Then you divide it by 14, whatever the support roller, I don't know what is it. But here, how do you decide on the roller itself? Because here you're calculating, you're doing force analysis, stress, whatever you call it, stress analysis, force analysis. But how do I know the roller, or the ball roller, what type I should use, what's dimension, what's things? Because that's what you need to design. You need to decide which ball roller you're going to use for your design. Here I don't see any things about the ball roller. The board also, you say the board. So what is the thing of the board? What is the thickness? What is any characteristic of the board based on your calculation? So you have to come to that. Like you have this, you go back now to go ahead to your drawing there of the board. Yeah. So here the board, this is the board, right?
Yes.
So we have the length, we have the width, and we have the thickness. How do you decide on those dimensions?
For example, the dimension we refer to the average bed size in Malaysia.
Okay, so then maybe you can decide on that one for the length and the whatever, because it has to be fit on the current bed, right? But the thickness, maybe you can design it. Because maybe that one, I'm not sure if they make them for 150 kilogram or more than 150. And this is your design it yourself, this one. It's not the one that they have. So make sure yours, you don't have to go like them, like maybe design for them for 500 kilogram. So if you design for 150, maybe you can find whatever the thickness that it shouldn't bend or it shouldn't whatever break or blah, blah, blah. Right, from that bending moment, bending stress, etc. Then you can get the thickness of the plate. Then I know that you designed the board. So if you find the thickness is 1 millimeter, then for example, you don't take 1. You say, okay, I'm going to take factor of safety 2, 3, 4, then I take 5, because that's what it is available. That's it. The same now, you have ball roller. How are you going to design the ball roller?
So actually, the load on the each ball roller that we calculated just now, that one will decide how much diameter of the ball roller that we will use, or what is the material, and
So
how much.
where is that calculation? For the ball roller? No, this is only the force. You calculate the forces. So this is, you have the ball roller, you play it, and you have the support. Since you have the force here, then you find the support here, the force here. So I have the force of the roller is 29 Newton. Okay? And then the support is 105 or whatever. So how do I get the roller itself that it can support that force without breaking, without whatever, moving smoothly, whatever it is. So I don't know what are the spec of the roller. Is it the diameter like you said? Is it the material? Then I have to deduce from this how this relate to that. And then I can decide. So because I'm going to buy that roller or make that roller, so I have to know what are the dimensions to make it. Is it this roller? Is it this roller? Is it this roller? Which roller? You know? So from this I have to get to that level, which I didn't see it here. But you have to do it the same way. Like you go with 150 kilograms, then you go down basically. And then any other calculation, or that's it? That's all. So here, so in your system, if you go to the drawer now, let's stop here. Go to the drawer. So in your system, you're adding a ball and that's it. In your system, component, what you need to buy? Just a ball, that's it?
Ball, and we have cylinder roller and shaft. This one.
Roller and shaft. How did you design the shaft?
This one the load. That's all.
But you didn't do the calculation for the shaft. Yeah.
We do, but we think that
Again, it has to be linked to which, again, engineering target. Make sure it is linked to that. So you need to design the shaft, the board, the roller, and
the rail and the roller.
you drill also, and
This one.
what is that?
Roller.
Roller, okay, roller we include it. Oh, you have roller, different roller.
Which
What
one?
is
This.
that one? Roller house.
This is roller house. It doesn't apply. Doesn't.
Just what to
doesn't
put the
take
roller.
any- Yes, just pull.
Okay, alright.
The roller here, we will install to the head and leg of the back.
That's fine, but I need to know what type of roller you need based on your calculation again from your engineering target. You have to find the spec of the roller before you buy it or you purchase it. You have to know. You cannot go, I need 5 rollers, okay? And he has like 10 types of rollers. Different material, different size, different, I don't know, mechanism maybe, whatever it is. So which one is suitable for you? You have to know, right, from your calculation.
You
Yeah.
already know, but we don't have.
No, but then you have to show me. You have to show here in your design. You start from 150 kilogram, blah blah blah. You find that you need a board with this thickness. And I understand. Now you solve the board. Now the same. I need this board. Is it related also to the 150 or related to something else? Another engineering target, efficiency, time, whatever it is. Then you have to show me from that how that influenced the roller. And then you come up with, if I'm using a roller made of steel, for example, you can fix as steel. So what is the dimension of the roller? Okay? Or what is the mechanism? If there is different mechanism, which mechanism is more suitable for me to fix that mechanism? Then what is, I keep at least one unknown, the diameter, the whatever, other size, I don't know what is it. Then I have to deduce that one. Then now I have the specs of all my 3, 4 components. The shaft, I have also to design. If I'm designing that shaft from aluminum, let's say fix it, I want it from aluminum for whatever reason, or because the shafts on the current bed made from that material, so I'm using the same. But then I will say, what is shaft? Is that solid? Wrong? Is it a C-section? Is it a hollow tube? Hollow tube. Then what is the dimension of the diameter, the thickness of that tube? In order when I put it and I put a thing, it doesn't go like this, you know, and crash or whatever it is, right? So I have to design it. Same. So each component has to be designed based on some of the engineering target. What I see now, you have one engineering target is the weight of your patient, basically. Nothing else. Maybe there's other, you can go through them, but it's kind of rethink on the same way, basically. Okay? Allah. Good then, huh?
Yeah. I just want to ask, so this board will be put on the bed itself, and then the mattress?
Mattress is under the board.
The mattress is under the board.
Yeah.
Sure.
So this board, so the patient will like lie on the board itself.
Yes. Before we transfer to the
Just to transfer.
That's the number. So still
And then they pull back
patient-
the board, and then they leave him on the new mattress.
So the patient, how do they initially go onto that board? So
We don't cover that part because I think we think that part cannot be handled
so
because
there's someone who still needs to like put the patient on top of the board.
because from ambulance we transfer to the ED bed.
Okay.
They must more fast. So they tak nak memang okay.
So this board.
No. What she said is, now you have it on the bed, right? You want to move it to the other bed. So that's why your board comes in, right? So then the patient will push him. You're going to add this board to the current bed?
But only certain parts of the ED. Our solution is only for the bed that used for mobile patients from point to point. It's not the one at the after the ambulance and then the ED.
The fixed one, the room no.
No, it's not the one.
So that's the one that moving around. So they take him from here to move to another room, for example.
Point to point.
Yeah. Then, that's why she said, how you gonna move him from that bed, the moving bed, to the fixed bed?
Process.
There. I mean, your mechanism, your solution, basically. You have to explain your solution.
Okay. Just now you see two beds, right?
Yeah.
So we just pull the board. Push. Sorry. Just pull the board to the bed, and the board just half of the bed, which is we have some spaces left. So the porters will go to the next bed and then just pull the patient with transfer sheet, which is transfer sheet is usually hospital will provide transfer sheet on the bed. So when they pull, it will.
So they move on to the other bed.
Yes.
Okay, so then you have to make sure also on that thing is, that's the safety here, you know.
Yeah. I'm concerned about the safety. So it rolls in this only one direction, or is it two-way?
Only one direction.
One direction.
It's two-way, but we fix the roller there. That's why at the first bed, the rollers can fit at the one bed. That's why we can only move to the other side. Once we move to the other side, and then we push again to this side, to the main bed.
And it has some safety features so that it can stop at certain angle or something, some rotation.
Now, the other thing is, this is the bed, and your plate is like lower than the bed, or higher, or how?
A bit higher. We must make sure to have a gap a bit because we want to avoid the friction between the board and the bed.
Okay, let's say this is the moving bed. I'm talking the moving bed, where you have your plate, right? So you have the mattress here, and then if you push your board, it will be like this, higher a bit. So how are you going to the patient to move him this way? You don't. No, it's okay. I want to understand. So this is your bed, right? And
I mean,
your thing is,
our bed is behind our board.
yeah, the board is high. So like this is the patient over here, huh? Okay? No, one more head. This is the patient. Okay? So the patient there, and you have your board over here. A little bit higher, you say, or
This one.
the patient is higher. So your board is lower.
Our solution is only to transfer.
Understood, understood. So your board is here, right?
Yes.
Then you push it. Is that right? Okay. So when you push it is a little bit lower, huh? You said, right? Then the patient. So this guy will be pulled by the sheet to move here. Is that right? No.
Yes, it's not like that.
Yeah.
Use your hands.
I don't understand. Like say this is the bed, this is your sheet, whatever it is. It is like this, right?
No,
Then you didn't do a nice drawing, so I don't understand.
patient on board. What we use
No. Patient comes on the bed first, on the board. On the board.
first for ambulance. The patient is transferred on the ED bed.
This moving bed, right? Which has your board.
Not yet.
Not yet?
Yeah.
Okay.
On the bed,
The bed of the ambulance, whatever, the bed of the hospital, whatever it's called.
we call stretches.
Huh?
We call stretches from the.
The stretcher, okay, the stretcher.
And then the stretches move to the point of triage, and then the patient got registered and whatsoever.
Oh, you give me like a little more details I don't need. I need the patient now on the bed that it has your board and you're gonna move it, that's all. That's your solution actually.
The way the patient is transferred on our board is that we don't have the solution for that. So the porters need to live on the bed that have our board.
Yes, okay. Forget that one. That's why I said the patient is already there. Okay? Now I want to see, this is the bed or your board? Which one is? The mattress or your board?